In this question here, we have a non-uniform beam. As you can see here, it's thicker here. You imagine the density would be the same. It is pivoted around this point. Its centre of mass could be anywhere along here. It's probably very badly drawn by me. But it is length is 0.75 meters long. Let's just say that is. And it's held at the other end by a string. We know the angle to the vertical from that, and we know the tension. The tension of the string is 5.1 newtons. The mass of the whole object is 1.2 kilograms. What we now have to consider are the moments around the pivot point. So you need the clockwise moments. The clockwise here is going to be the weight times by the perpendicular distance d. So we could just write that down here. Is going to be d times mg. I'm going to leave it mg. We know what m is up here. Now the anti-clockwise, that's going to be the vertical component here times by the distance there. So we can have the distance of 0.75 meters times by the component of t. And the component of t would be, well, it's 5.1 times, we're looking for the adjacent, aren't we? So it's going to be cos 40 degrees. So let's put this out. What are we trying to find? We're trying to find the length d. So we have 0.75 times 5.1 cos 40 is equal to d times, let's put that in, 1.2 times 9.81. And then we just simply rearrange that to get d on its own is equal to 0.75 times 5.1 cos 40 all over 1.2 times 9.81 equals something in meters. And if we look here, we expect it to be less than 0.75. In fact, we look more of the mass is this end, so we less than half of that.